Hello again. It's time to do another lesson. Today we're going to talk about section 1.4, quadratic equations. The objectives for today's lessons include number 1, the zero factor property, number 2, the square root property, number 3, completing the square, number 4, the quadratic formula, number 5, solving for a specific variable, and number 6, the discriminant. Let's start off with the zero factor property. The quadratic equation, if a quadratic equation is written in one variable, it can be written as ax squared plus bx plus c equals 0. A, b, and c are all real numbers. A is not 0. And the reason a can't be 0 is because if it was, the quadratic term would be gone and we don't even have a quadratic anymore. This gives the form standard form. The zero factor property. If I have a quadratic equation that's easily factorable, then I can factor that quadratic, set those factors equal to 0, solve each of those factors, and that'll give me the values for x. So if you think of it, if I'm multiplying two numbers together and I get 0, what must be true? Well, as it says in the zero factor property, if a and b are complex numbers, if a times b equals 0, then that means either a is 0 or b is 0, or maybe even both of them are 0. Here's an equation we're going to solve using the zero factor property. It says solve 6x squared plus 7x equals 3. Well, let's use the zero factor property. The first thing I need to do is make this in standard form. So to put this quadratic in standard form, I will subtract 3 from both sides. So subtracting 3 from both sides gives me 6x squared plus 7x minus 3 equals 0. And now we have to factor this. Well, as we talked about in R4, there's different ways of factoring. In this particular one, my a is 6 and c is negative 3. So if I take a times c, that gives me 6 times negative 3, and that's going to be negative 18. So what I need to do now is think of two numbers whose product is negative 18, but when I combine them or add them, I get my b value here in the middle, which is 7. Two numbers that multiply together to get negative 18 tells me that one of the numbers is positive and one of the numbers is negative. When I add them together, I get a positive 7, so that tells me the bigger of the two numbers has to be positive. Well, that's going to be 9 and negative 2, because 9 times negative 2 is negative 18. 9 plus negative 2 is 7. So we're going to break up that middle term of 7x using coefficients of 9 and negative 2. And as I said in the last video, if possible, if there's a positive and a negative, write down the negative one first and then the positive one. It tends to make things a little easier. So I'm going to rewrite this quadratic as 6x squared minus 2x plus 9x minus 3 equals 0. And as a reminder there, what happened is that negative 2x plus 9x gives me that 7x that I started with. So my equation is the same, I just have it looking different. Factoring by grouping, my first two terms, I can factor a 2x out of that. Taking a 2x out leaves me with 3x minus 1. And if I factor this positive 9x minus 3, I can factor out a plus 3. And taking that 3 out of the 9x plus 3 leaves me with 3x minus 1 equals 0. I now have two terms. Those terms factor into 3x minus 1 and 2x plus 3. So now I have two factors. One of them is 3x minus 1, and the other one is 2x plus 3. When I multiply them together, I get 0. Well, the only way this is true is if one of those factors is equal to 0. So either 3x minus 1 equals 0, or 2x plus 3 equals 0. To solve the first equation, we will add 1 to both sides. and that gives me 3x equals 1. And then to get x by itself, I will divide both sides by 3, and x equals 1/3 is one of my solutions. On the other one, I have 2x plus 3 equals 0. To get x by itself, I will subtract 3 from both sides. 2x equals -3. Divide both sides by 2, because 2 divided by 2 is 1, and I want x by itself, so there we go. So x equals -3/2. So my two possible values for x are 1/3 and -3/2. And I can actually write this in something called set notation. X is equal to, I'm going to use braces. Anytime you see braces, that means set notation. So x is equal to the set of numbers containing. And when you write your answers down, it's always best to write them in order from smallest to largest. So we have -3/2, comma, 1/3. And that is my solution to this problem. Another property to solve is called the square root property. Now, if you remember on that last problem we did, and I'll go back to it real quick, this last term problem had a quadratic term, the 6x squared. It had a linear term, the 7x, and the 3. Well, if that linear term is gone, so we have something that takes the form of x squared equals k, then we can get the quadratic term on one side, get everything else on the other side, take the square root of both sides, and we're good to go. So here's an example, super basic, x squared equals k. Well, to get x by itself, I would take the square root. Remember an equation, if you do something to one side, do it to the other side, and we're good to go. So taking the square root of both sides, the square root of x squared is x. The square root of k is, and this is important here, plus or minus the square root of k. So when you're solving equations, anytime you take a square root, there's going to be a plus and a minus. If k is positive, that's what this says right here, if k is positive, then both solutions are real. If k is negative, if k is less than 0, then both are called pure imaginary. And if k is 0, well, the square root of 0 is just 0. And so that would have one solution, and that's sometimes called a double solution or a double root or a double zero. Lots of ways that's been referred to. Okay, so here are three problems that we're going to solve by using the square root property. Part A, x squared equals 17. Well, this is set up for us. I've got x squared on one side. I've got the constant on the other. If I was to take the square root of both sides, take the square root of x squared, take the square root of 17. The square root of x squared is simply x. And the square root of 17. 17 is not a perfect square. There are no perfect squares that go into 17. So the square root of 17 is simply the square root of 17. However, again, this is an equation. So because it's an equation, it's going to be plus or minus the square root of 17. So again, that number 17 is a positive number, so we're going to have two answers. And they're both real. Part B, x squared equals negative 25. Well, x squared is already by itself. I've got a negative 25 on the other side, and that's just a constant. I will take the square root of both sides. The square root of x squared is x equals. Now the square root of negative 25, what we have here is we have a square root of negative 1 times 25. So because I'm taking the square root of both the negative 1 and the 25, you can actually think of it as doing two separate square roots. And if you remember from back in high school, the square root of negative 1 is I. Let me write this down here. The square root of negative 1 equals this lowercase I. So that means it's an imaginary number. And of course, up above, we also have the square root of 25. And of course, the square root of 25 is 5. Now, we are solving an equation. So because we're solving an equation here, the square root of negative 1 times 25 is going to be plus or minus. And then the square root of 25, you write the number first, and the I always comes last. The square root of 25 is 5, and the square root of negative 1 is I. So there's the answer for part B. And part C. This one looks a little interesting. I've got x minus 4 squared equals 12. Well, that x minus 4 is my variable, and that thing is being squared. So just like in the previous two, I'm going to take the square root of both sides. Now that x minus 4 is just one little thing that's being squared. So if I take the square root of something that's squared, basically that eliminates the square. So the square root of x minus 4 squared is x minus 4. Square root of 12. Well, the square root of 12. 12 can also be written as 4 times 3. And the reason I choose 4 is because 4 is a perfect square. Obviously, 12 can be written also as 6 times 2. But neither 6 nor 2 is a perfect square. So if you recall, when simplifying radicals, you want to try to break them up into perfect, in this case, squares. So the square root of 12 is the same thing as the square root of 4 times 3. And I'm going to go ahead and rewrite this as a separate time here. I have x minus 4 equals. If I am taking the square root of a product, in this case 4 times 3, I can break that up into two pieces. So the square root of 4 times 3 is the same thing as the square root of 4 times the square root of 3. So I have x minus 4 equals. The square root of 4 is, and again, because it's a square root, it's plus or minus. The square root of 4 is plus or minus 2. And the square root of 3, there are no perfect squares there. I can't make it any simpler, so it's just going to be the square root of 3. I don't have to write a plus or minus on that square root of 3 because I've already written the plus or minus once. Keep in mind we're trying to solve here. And so when you're solving, that means get x by itself. Well, in order to get x by itself, I have to get rid of that minus 4. So I will add 4 to both sides. Board's glitching a little bit. Sorry about that. This 4 just doesn't want to work. There we go. So I'm going to add 4 to both sides. Well, on the left side, the 4 is gone, so I'm just left with x equals. On the right side, I can't combine those. 2 square roots of 3 and 4 are two different things. I can't add them together. So since I can't add them together, I'm going to keep them both. And I'm going to go ahead and write the 4 first. So I have 4 plus or minus 2 square roots of 3. And that is the answer. There's your value for x. If you wanted to, or if you have a problem saying, you know, x happens to be the number of seconds that it took to do something or whatever. In that case, you would probably go ahead and use a calculator and actually calculate that value of 4 plus into a decimal, 4 minus 2 square roots of 3, and get it into some decimal. Another method to solve quadratics is called completing the square. There's several steps involved in completing the square. We're going to work a couple problems of these, but here's the process. So it says to solve ax squared plus bx plus c equals 0, where a is not 1, or not 0. Use completing the square following the steps. So here's the problem. In order to complete the square, a, or that leading coefficient, has to be 1. Well, if it's not a 1, if I can take that entire equation and divide everything by a, it will turn that leading coefficient into a 1. Now that it's done, it says rewrite the equation so that the constant term is on one side, which means if it doesn't have a variable, put it on the other side. Keep your variables on one side, everything else to the other side. Square half the coefficient of x, add that to both sides, factor the trinomial. You chose a specific value for a reason, so you can make that a perfect square, and then use the square root property. Okay, this is very, very wordy, and it makes a whole lot more sense if we just jump into it and do one. Okay, so we're going to start off with a very simple one. In this case, my leading coefficient is already a 1, so I don't have to worry about dividing everything by stuff. Okay, so completing the square. Step number 1, make sure that the number in front of x squared is 1, and it is. Step number 2, move the constant to the other side. So here's how I'm going to do this. I've got x squared minus 4x. Now, to make that negative 14 go away, I'm going to add 14 to both sides. So on the left side, I have a negative 14 plus 14, which is 0. I'm not going to write that 0 down, but I will leave a space here. We're going to use that space in just a moment. Equals 0 plus 14, of course, is 14. So now I have an equation. Okay, so here goes the next step to completing the square. I want to know what is b. And remember, the quadratic is ax squared plus bx plus c equals 0. So b is negative 4 in this case. And if you'll stay with me and pay attention to how I do this, the factoring piece, it falls together so nicely. So I'm going to come over to the side here. I'm going to say, okay, for this problem, b is negative 4. Going through the steps on the previous slide, I need to take half of that negative 4. Well, okay, so b, sorry about that, a little glitchy on the writing. b over 2 is equal to negative 4 divided by 2 is negative 2. That number is very important. It's going to come back in just a second. The last thing we're going to do is we're going to take that b divided by 2 and square it. So I'm going to take that negative 2 and square it. Negative 2 times negative 2 is positive 4. That number is very important also. Okay, so half of b squared is 4. In order to complete the square, now real quick, little segue here. What does it mean to complete the square? Let me show you in a picture form. Here is a square. And you're going to say, well, no, it's not. That's not a square at all. Okay, well, if I was to ask you to walk up to this board and complete the square, what would you do? Well, you would walk up and you will add this rectangle right here. So because we added that, that made the square complete. So let me say this again. In order to complete the square, you have to add something. So here's a picture version of us actually adding something. Now let's do it mathematically. To complete the square of x squared minus 4x, I'm going to add 4. Remember, I'm working with an equation here, which means if I have an equation, if I add something to one side, I must add the exact same to the other side to keep the balance. Otherwise, if I had a balance and I just added something to one side, it would tip over. Well, the only way to balance is to add that back to the other side. So because I added this 4 to the left side, I will add the 4 to the right side. So that gives me x squared minus 4x plus 4 equals 18. Because we completed the square, we made the left side a perfect square. We added the 4. Now, a while ago, I told you that this negative 2 was going to be very important, and here's where it comes in. What two numbers multiply together to get 4 and add together to get negative 4? And those numbers would be negative 2 and negative 2. Negative 2 times negative 2 is 4. Negative 2 plus negative 2 is negative 4. So this left side is going to factor into x minus 2 times x minus 2, but I'm not going to write it that way. x minus times x minus 2 is the same thing as saying x minus 2 squared. My right side is 18. And if you think about it, this problem now looks very much like, let me go back 2 slides here. It looks very much like problem number C. Okay? Just different numbers there. Go back to where we are. All right. So because my left side is a perfect square, I'm now going to take the square root of both sides. So I will take the square root of the left side and the square root of the right side. The square root of x minus 2 squared is x minus 2. The square root of 18, well, are there any perfect squares that go into 18? 18 can be written as 9 times 2. And again, the reason I chose 9 is because 9 is a perfect square. 3 times 3 is 9. Okay, so breaking this up, I have x minus 2 equals, the square root of 9 is plus or minus 3. The square root of 2 is, well, I can't do that. It's the square root of 2. And finally, I will add 2 to both sides. X equals 2 plus or minus 3 square root 2. And there's the answer for that problem. But what about when a is not 1? Well, in this particular problem, as I look at it, a is not 1. My a is 9. So I need to get rid of that. So I could get rid of that by dividing everything by 9. So let's just go ahead and do that. I will divide everything by 9. 9 divided by 9 is 1, so there's x squared, minus 12 divided by 9. Well, 12 divided by 9, it doesn't divide easily at all. So 12 over 9, that does reduce though. 3 goes into 12 4 times. 3 goes into 9 3 times. So 12 over 9 is the same thing as 4 over 3. X plus 1 equals 0. Now a is 1. So now we're going to follow the steps of completing the square, just like on the last problem. Yes, I know there's a fraction there. No, it's not a big deal. So complete the square. I need to get the 1 on the other side and keep the variables on the left side. So I will subtract 1 from both sides. X squared minus 4/3 x. I'm going to leave some space here. Subtracting 1, it goes away. And subtracting 1 on the left side gives me a negative 1. So now it's time to complete the square on this polynomial here. So we start off with what's b. b is the coefficient of my x term, so b is negative 4/3. If I take half of that, I get negative, see, half of 4/3 would be 2/3, so negative 2/3. And again, that number right there is going to be super important. We'll come back to that in a moment. Next thing I need to do is square both of those, so half of b squared. Well, if I took negative 2/3 and squared it, a negative times a negative is a positive. 2 times 2 is 4, and 3 times 3 is 9. So half of b squared is 4/9. So again, to complete the square, I have to add something. What do I add? Well, I add half of b squared to complete the square. So I will add 4/9. Anything I do to the left side, I must do the exact same thing to the right side. The left side is now a perfect square. And remember, I've told you that b halves is a very, very important number. That negative 2/3, here it comes. To factor the left side, it's going to factor into x. it's always going to factor into whatever the variable is. In this case, it's x. So there's my x. What goes with the x? Well, b halves does. b over 2 does. What is b over 2? Well, in this case, it's a minus 2/3 squared equals. Okay, adding this together, you can use your calculator or whatever you're doing. If you think about it, 1 is the same thing as negative 9 over 9 plus 4 over 9. Well, negative 9 over 9 plus 4 over 9, that's going to be minus 5 over 9. And this looks just like the problem on the last screen. It looks like problems at C, 3 slides ago. I've got a perfect square, so let's go ahead and take the square root of both sides. Okay, the left side is pretty nice and easy. It just gets rid of the square, so I have x minus 2/3. And on the right side, there goes the square root of a negative number. So remember, because we're taking the square root of a negative number, we're going to end up with an I. So plus or minus the top, square root of 5. Well, there's no perfect squares that go into that, so the top is just the square root of 5. Over the square root of 9, well, that's 3. And because we had that negative sign there, that's going to give us this I here. So the square root of negative 5/9 is plus or minus the square root of 5 over 3i. I will now add 2/3 to both sides. So x equals 2/3. There you go. It's positive because I added it. Plus or minus the square root of 5 over 3i. And there's your answer. Next problem. Quadratic formula. Okay, so before we actually tell you the quadratic formula, before we actually use the quadratic formula, what I'm going to do is take this quadratic formula, this quadratic that's in standard form, ax squared plus bx plus c equals 0, and I'm going to use completing the square and solve it for x. Now, as I go through this, know that I'm not going to have you at any point actually regurgitate this to me. I'm not going to put this on a test saying, hey, here's a quadratic, solve for x. Using the quadratic formula, c is my constant, so I need to move it to the other side. So I will subtract c from both sides. ax squared plus bx, I'm going to leave some space here, equals negative c. Well, to complete the square, the coefficient on x squared has to be 1. So to make it a 1, I have to divide every piece of this by a. So I now have x squared plus b over a x, leave some space, equals negative c over a. So what is my middle term now? I'm ready to complete the square. My middle term, now this might be a little confusing because I'm still using b. I'm going to take this middle guy, which is my b coefficient, which is b over a. I'm now going to take half of that. So b over 2. Well, if I took b over a and took half of that, remember the word of means multiply, so b over a times 1/2. When you're multiplying fractions, you multiply straight across. B times 1 is b, and a times 2 is 2a. All right? So b over 2 half of b is now going to be b over 2a. And now I'm going to take half of that, or take that b halves, and square it. Well, if I square b, b times b is b squared. And if I take that 2a and square it, I get 4a squared. Little glitchy here. Sorry about that. Okay, so in order to complete the square, I'm going to have to put b squared over 4a squared on both sides. So that's what I'm adding to both sides. Plus b squared over 4a squared. Plus b squared over 4a squared. Well, the left side, because I specifically chose to add b squared over 4a squared to both sides, I now factor the left side, and again, b halves is going to come into play here. I get x, always starts with an x or whatever your variable is, and then I'm going to put b halves here. Now this b halves is positive, so I'm going to put plus b over 2a squared equals, all right, the other side. I can't add those because I don't have a common denominator. So in order to add those together, put a little space down here. In order to add negative c over a plus b squared over 4a squared, I have to have a common denominator, which means I need to take that first fraction of negative c over a and multiply it by 4a over 4a. And here's what that's going to look like. I'm going to take 4a over 4a, because remember, anything divided by itself is 1. I'm going to multiply that by negative c over a plus b squared over 4a squared. So cleaning up that left side there, I've got a negative 4ac over 4a squared plus b squared over 4a squared. And now that my denominators are the same, sorry about that. Now that my denominators are the same, I can add those together, and I'm going to flip it around. B squared minus 4ac over 4a squared. Okay, so I'm going to take that guy and bring it up here. B squared minus 4ac over 4a squared. Well, I'll now take the square root of both sides. Let's just go to a different color altogether here. Taking the square root of both sides. The square root of the left side cancels the square, so I have x plus b over 2a equals the right side. Taking the square root of a fraction means take the square root of the top and the square root of the bottom. Well, the top is going to be the square root of b squared minus 4ac divided by the square root of 4a squared. Well, the square root of 4 is 2, and the square root of a squared is a. And remember, because I took a square root here, there has to be a plus or minus in front of it. I will now subtract b over 2a from both sides, and that's going to look like this. I'm going to scoot way over to the left side here. X equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And just like before, because my denominators are the same, I can combine the numerators into one piece. So I now have x equals, combining the top, negative b plus or minus the square root of b squared minus 4ac all over 2a, and I have solved for x. That is the quadratic formula. The solutions of the quadratic equation ax squared plus bx plus c equals 0 when a is not 0 is the quadratic formula. If you remember back in high school or some other class, you might have actually sung the quadratic formula, because I can sing that to the tune of Pop Goes the Weasel. So let me go do that for you real quick. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And there you have your quadratic formula. You don't have to sing it. You don't have to memorize it. You can have it written down in a cheat sheet. There are two methods to solve a quadratic that will always work. And saying always in math doesn't happen very often. One method that will always work is completing the square. And as y'all saw from a problem earlier, that can get quite tricky. Another way, quadratic formula. The quadratic formula always works. When I scratched my camera, quit following me. Let me see. There we go. Good to go. All right. So let's use the quadratic formula to solve an equation that has real solutions. Well, in order to use the quadratic formula, you must put it in standard form, meaning it must equal 0. This equation does not equal 0. So to make this equal to 0, I will add 2 to both sides. That gives me x squared plus 4x plus 2 equals 0. Now that it is in standard form, and folks, in the quadratic formula, I don't care what a is, I don't care what b is, I don't care what c is. A can't be 0. We can use the quadratic formula. Let's identify a, b, and c. So for this equation, a, the coefficient in front of the x term, is 1. B, the coefficient in front of the x term is a positive 4, so b is 4. C is my constant. C is a positive 2. Now that I've identified a, b, and c, we can use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. Plugging in what we know. X equals negative, well, b is 4. Plus or minus the square root. Okay, I'm going to pause right here. We're going to come back and talk about this specifically in a little bit, but by plugging all this stuff in and working it through, it can get very messy. What I like to do is work the inside of the radical separately. So I'm going to take this b squared minus 4ac and work it off to the side. Well, okay, so b. Well, b is 4 squared minus 4 times a, which is 1, times c, which is 2. 4 squared is 16 minus 4 times 1 times 2. Well, 4 times 1 is 4. 4 times 2 is 8, so minus 8. So 16 minus 8 is 8. So b squared minus 4ac, I'm going to put it right back in here, is 8. All over 2 times a, which is 1. And now we can clean that up. Let's talk about the square root of 8 real quick. The square root of 8. Are there any perfect squares that go into 8? Yes, there is. 4 is a perfect square. 4 times 2. So the square root of 8 is the square root of 4 times the square root of 2. The square root of 4 is 2. The square root of 2 is, I don't know, it's the square root of 2. All right, so x equals -4 plus or minus. If you'll notice, I didn't talk about this being plus or minus over here when I was doing the square root of 8. And the reason I didn't is because the plus or minus is automatically built into the quadratic formula. So -4 plus or minus 2 square root of 2 over 2. And the only thing about this, folks, is it's not finished. This will reduce. If you'll notice, the top has two terms. One term is -4, and the other term is plus or minus 2 root 2. And if you'll notice, I could actually factor a 2 out of the top. So if I took a 2 out of the top, I would be left with -2 plus or minus the square root of 2. So what we did there was factored out that greatest common factor. Remember, that's rule number 1 in factoring. Always factor out the greatest common factor. Divided by 2. Sorry about all the 2's up here. And the reason we do that is because there's a 2 on the top now multiplied by something. There's a 2 at the bottom. Those will cancel to 1. So my final answer is x equals -2 plus or minus the square root of 2. Which means there are two real solutions to the quadratic given. However, this quadratic does not factor. So all of the different things we looked about at factoring will not work with this. But again, the quadratic formula will always work. Next problem. We are going to solve a quadratic formula that has non-real complex solutions. This thing has imaginary solutions. We're going to take the square root of a negative number, and that's where the imaginary comes in. So again, starting off, we look at this quadratic, and it is not in standard form. So the first thing I want to do is put it in standard form. I will subtract x from both sides. I will also add 4 to both sides. And when I'm talking about both sides, remember to think about that equal sign being a fence. You know, if I do something to one side of the fence, do it to the other side of the fence. Well, on the left side, I have all the terms, and let's put them together, put them in order, descending powers. So we have 2x squared minus x plus 4 equals, I got rid of everything on the other side, so that's just 0. I now have a quadratic equation in standard form. I can identify A, B, and C. A is the coefficient of my quadratic term, so A is 2. B is the coefficient of my linear term. Here's my linear term. And the number in front of that x is a -1. C is my constant, which is a +4. So there's my A, B, and C. Here we go, quadratic formula. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So we will plug our stuff in. X equals -b. Well, b is -1. Notice I put the -1 inside parentheses. Don't just write the negative down for the b and just put a 1 beside it thinking that takes care of it, because it doesn't. It's -b, so -1. Plus or minus, okay, square root. Let's do that b squared thing off to the side again. B squared minus 4ac. B is -1 minus 4, that's squared, minus 4 times a, which is 2, times c, which is 4. -1 squared, that would be -1 times -1. Negative times a negative is a positive. 1 times 1 is 1. Minus 4 times 2 times 4. 4 times 2 is 8. 8 times 4 is 32. So it's 1 minus 32. Well, 1 minus 32 is -31. So the b squared minus 4ac is negative 31. So back to plugging into my quadratic equation. Negative b plus or minus the square root of negative 31 all over 2 times a, which is 2. Let's clean this up. A negative, negative 1 is a positive 1, plus or minus the square root of negative 31. Now, because there's a negative there, there's going to be an I, because the square root of negative 1 is I. And then we have the square root of 31. Well, 31 is a prime number. There are no perfect squares that go into 31, so it's just going to be the square root of 31. When I'm doing these, I tend to write the I before the square root because I don't want you to think that it's inside there. Also, if you'll notice, when I write that square root symbol, I put this little tail thing down on it. That's to indicate that I understand that that is where that square root does, in fact, end. And the bottom is 4. 2 times 2 is 4. Okay, I can't factor anything out of the top. That answer is acceptable. We are going to talk about complex numbers and putting them in standard form for a complex number. So I could rewrite that. If you remember earlier, we took fractions if the denominators were the same and we combined the top. Well, when we're dealing with complex numbers, it's very common to split them up. So instead of writing 1 plus or minus I squared root of 31 over 4, we'll break it up into what's called the real part and the imaginary part. The real part's going to be 1 over 4. Here's my plus or minus. The imaginary part is going to be the square root of 31 over 4. And you're thinking, uh-oh, he forgot the I. No, he didn't. I'm going to put the I over here to make it in complex form. So either one of these answers are fine. When you're doing your homework on the computer, it's going to want it a specific way. It'll probably tell you how it wants it. But I want you to know both of those are, in fact, correct answers. Using factoring and the quadratic formula. Okay, so on this problem here, I have x cubed plus 8 equals 0. If I wanted to solve this, this is a cubic equation, and because it's a cubic, I know that it's going to have 3 solutions. They might be real, some might be imaginary, whatever, but I know there's 3. Well, if you remember in factoring, we had one of the properties for a sum of cubes, and if you'll notice, x cubed is a perfect cube, x times x times x. 8 is also a perfect cube, 2 times 2 times 2. And if you remember, the sum of cubes, x cubed plus y cubed, would factor into x plus same sign y times x squared opposite sign, so minus x times y, always plus y squared. Okay, so that was just a property for factoring a sum of cubes, and so we're going to apply that to this. Well, for this particular problem, x cubed plus 8 equals 0. Well, that's the same thing as saying x cubed plus 2 cubed equals 0. And I wrote it that way so we could use this little formula here. So in the case of the problem given, my x is x, but y is going to be 2. So this factors into x same sign 2 times x squared opposite sign, so minus x times y, so 2x, always plus y squared, so 2 squared is 4, equals 0. And if you recall from factoring, I said that when you have a sum of cubes or difference of cubes, I mean, that is what it factors into. I mean, if it factored into something else, then there'd be another thing. So this whole x squared minus 2x plus 4, it doesn't factor. So I can still solve it just like the previous problem. Right here, I could solve it by using the quadratic formula. Okay? Okay. So x plus 2, I can't do anything with that. So what about that second piece? I know that when I solve this, that remember I've got two things multiplied together. Two things multiplied together. The only way to make the answer be 0 is one of those things has to be 0. So at this point, I know that either x plus 2 equals 0 or x squared minus 2x plus 4 equals 0. Well, this first one, x plus 2 equals 0, if I subtract 2 from both sides, I know that x is equal to negative 2. So that right there is one of my solutions. I don't want to lose it. When I give my final answer to this question, I need to have 3 answers. Well, that's one of them. The other one's going to come from this that does not factor. So it's a quadratic. My a, the coefficient of my quadratic term, the coefficient in front of x squared is 1. B, the coefficient of my linear term, the coefficient in front of the x is negative 2. And C, my constant, is 4. The quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'll go off to the side and do my b squared minus 4ac. Plugging everything in, b is negative 2 squared minus 4 times a, which is 1, times c, which is 4. Negative 2 squared is 4 minus 4 times 1 times 4 is 16. 4 minus 16 is negative 12. Go back to the quadratic formula. Let's start plugging stuff in. X equals negative. Well, b is negative 2 plus or minus the square root of negative 12. That was my b squared minus 4ac that I've already solved. All over 2 times a, 2 times 1. Cleaning up that numerator, negative 2 would be 2 plus or minus. Okay, the square root of negative 12. That would be, first of all, it's negative, so there's going to be an I. 12 can be written as 4 times 3, because 4 is the biggest perfect square. Four times 3. 4 is the biggest square that goes into 12. The square root of 4 is 2, so 2i square root 3. Sorry about the glitchy board over there. That's 2i square root of 3. So the square root of negative 12 is 2i square root of 3 all over 2. I can factor a 2 out of the top that will cancel with the bottom, and that'll leave me with x equals 1 plus or minus I square root 3. And there's your answer. So I said 3 answers because it's a cubic. X is equal to negative 2. That's 1 answer. X is equal to 1 plus I root 3. That's 2. X is equal to 1 minus I root 3. That's 3. So we do have all 3 of our answers for this problem. This says to solve each equation for the specified variable, use plus or minus when taking a square root. So the first problem, a equals pi d squared divided by 4, solve for d. That means let's get d by itself. This is called a literal equation. So to solve this literal equation, the first thing I need to do is multiply both sides by 4. Multiply the left side by 4. Multiply the right side by 4. That 4 cancels. I have 4a equals pi d squared. I'm solving for d. Well, that d squared is multiplied by the pi, so we need to divide both sides by pi. I now have 4a over pi equals d squared. To get d by itself, I need to unsquare it. So I will now take the square root of both sides. I'm also going to turn this around while I'm doing it. I'm going to do the first. So the square root of d squared is d equals, and the square root of 4a over pi. I'm just going to be a little lazy on this one. I'm going to say that's going to be plus or minus. The square root of 4 is 2. And then I'm going to have the square root of a over pi, and I'm just going to call that good for now. We can work on other situations involving square roots later, but for right now, I do have d by itself. There you go, 2 answers for d because d was squared. Part B, solve for t when r is not 0. The first thing I would need to do is pull the k over. So I will subtract k from both sides. So rt squared minus st minus k equals 0. And folks, for sake of time, I am not going to spend the time actually doing that one. Basically what I'm doing is building the quadratic formula again like I did earlier. I'm going to have some sign differences because this is a negative s and a negative k, but everything that we did on the quadratic formula is going to come into play here again except for signs. So I'm going to leave this like it is and let you think about it, and if you want to challenge yourself to complete this one, I'll leave that for you. Okay? Okay, so I spent a lot of time already when solving the quadratic formula. I would do that b squared minus 4ac separately. Well, that thing actually has a name. It's called the discriminant. In the quadratic formula, b squared minus 4ac is the discriminant. And the discriminant tells us a lot about what the answers will look like. And we've had 2 of these happen for us tonight. So the discriminant. If the discriminant is positive and a perfect square, we're going to get 2 nice real solutions, and they're going to be rational, meaning there's not going to be any square roots in the answers. They're going to be nice answers. They might be fractions, but there's not going to be radicals in the answers. If the discriminant is positive but not a perfect square, we've seen this, we're going to get 2 answers. They're going to be real, but those real answers will be irrational, meaning those answers will have a square root still in them when they're done. We did not have this happen tonight, but if the discriminant is 0, we will only have one solution, and that one solution is going to be called a double root, okay? Because if it's quadratic, a quadratic has to have 2 solutions. Looking at the quadratic formula, think about it. If the quadratic formula says x is equal to negative e plus or minus the square root of, well, if the square root of happens to be 0, if you think about it, the plus or minus is gone. So in that case, the 0 is going to be located simply at negative b over 2a. Okay, there's only one. And again, it's a double root or a double 0. We also had this happen tonight. If the discriminant is negative. If the discriminant is negative, it tells us, hey, you have 2 answers, but they're going to be imaginary because you're taking the square root of a negative number. It's not real, so it's imaginary. So we're going to look at 3 of those. These 3 problems simply say, hey, what's the discriminant? So we're going to find the discriminant, and then we're going to look at that discriminant, and from that determine what the answers look like. We're not going to solve these 3. We're just going to talk about what the answers will look like if we were to solve. Okay, so letter A, 5x squared plus 2x minus 4 equals 0. First of all, it's in standard form. Yes, it is. Identify your A, B, and C. A is 5. B is 2. C is negative 4. So the discriminant, b squared minus 4ac. Plug those numbers in. Well, b, that would be 2 squared minus 4 times a, which is 5, times c, which is negative 4. 2 squared is 4. Then I have a negative 4 times 5. Negative 4 times 5 is negative 20. Negative 20 times negative 4. Negative times negative is positive, so negative 20 times negative 4, positive 80. So the discriminant for this problem is 84. 84 is positive, so we know it has 2 real. 84 is not a perfect square. Not perfect square. So because it's not a perfect square, we're going to have 2 real irrational roots. Part B. Well, I can't identify A, B, and C on Part B because it's not standard form. So before I can do that, I have to put it in standard form. I will do that by adding 25 to both sides, giving me x squared minus 10x plus 25 equals 0. So A, the coefficient on the x squared is 1. B, the coefficient on the x term is negative 10. C, my constant, is 25. The discriminant, b squared minus 4ac. Plugging our numbers in, b is negative 10 squared minus 4 times a, which is 1, times c, which is 25. Negative 10 squared, negative 10 times negative 10 is 100. Minus 4 times 1 is 4, times 25 is 100. 100 minus 100 is 0. That means we're taking the square root of 0. So all I have is 1 real, rational root. And again, that's going to be called a double root or a double zero. And part C, we have a quadratic. It's already written in standard form for us. We can identify A, B, and C by looking at it. A, the coefficient of my x squared is 2. B, the coefficient of x is negative 1. C, my constant is 1. The discriminant, b squared minus 4ac. Plug in what we know. B is negative 1 squared minus 4 times a, which is 2, times c, which is 1. Negative 1 squared, negative 1 times negative 1 is 1, minus 4 times 2 times 1 is 8. 1 minus 8 is negative 7. My discriminant is negative. Because the discriminant is negative, I know I have 2 complex or imaginary roots. And folks, that is it for 1-4 quadratic equations. Again, I ask that if you're having any problems with any of the homework or whatever, text me, send me an email, shoot me a message in Canvas, whatever it takes. I want everybody to be successful. I'll come back on tomorrow and post another video on the next section. Y'all have a great day.